Hello guys, and welcome back to the playlist brought to you by IEEE Student Branch VIT Pune about object-oriented programming using C++. And so far we have seen multiple things in the playlist up until now, but there still are many things that are left, and one of them is static members. Now this video has about 3 agendas. First is we want to understand what the static keyword is. Like, why exactly do we need something like this? And second, we'll have a look at static variables. And finally, we'll also talk about static methods briefly. Let's kickstart this video by focusing on our first agenda, which is understanding the static keyword. Over here, I have an example. What we have done is we have created a class which represents a car, and it has 3 attributes. First is the color of the car, or rather the vehicle. The second is the company, and third is the model of the car. What we have done is we have created 3 objects using that car class, and all of us know that class is nothing but a blueprint using which we can create objects by setting different values to the attributes which are specified in the class definition. So here we have created 3 objects. The first is a Ford Mustang of red color, the second is a blue Toyota Prius, and the third one is a green Volkswagen Golf. Now, in this case, we can think of one problem statement, that is counting the number of objects that have been created. Suppose I want to know all of the cars which are created using this car class. How would I do that? Now, one possible approach to this problem would be to add another attribute. Let's name it in this case a regular attribute, just like the color, the company, and the model. Will introduce one other attribute which, let's say, is named count, is of type integer, and we can try and think that we'll be able to increment this attribute each time an object is created. But something different will happen in this case. Because every time an object is created, all of the attributes of that objects, all of the attributes rather, are pertaining to that object instead of the class. So what will happen is, if we create an object, let's say object 1, the counter will be initialized to 0. And if we create another object, let's say object 2, the counter will again be initialized to 0 since it is pertaining to that object instead of the class in general. And again, in case of object 3, the counter will again be 0 as it was the first 2 times, because in this case again, the counter will be in the scope of the object rather than in the scope of the class. So the counter only knows about the object which has been created and the object in which it resides, instead of all the other objects which also exist, or rather coexist with this object as well. So what we can do here is, here we can think of one concept, that is, what if we had a variable which instead of belonging to an object belonged to a class. Now, what do I mean by that? Just like an object has its own attributes, and in this case object 1 has an attribute counter which is set to 0, a class can also have attributes that belong solely to it, and these attributes are known as static attributes. Let's compare static attributes and normal attributes with help of a little example. Let's say for object 1, we change the counter's value from 0 to 1. Now that change won't be reflected for object 2 because object 2 is basically unaware of the existence of object 1, let alone its attributes. Now what will happen in this case is, even though the counter for object 1 is set to 1 after the change, the counter of object 2 will remain intact. So how can we use static attributes in this case? Static attributes are not just attributes which belong to a class, but these are also the attributes which are shared by all the objects that are made using that class. So what will happen is, initially when we have created no objects out of it, the counter, which is static, will be 0. Then after we create object 1, what we can do is we can tap into this attribute which belongs to the class, and we can also do that using 2 ways. First is using the class name, and second is using the name of the object. So what we'll do is, when first object is created, we'll tap into this attribute and increment it. In this case, the counter will now be set to 1. After object 2 is created, we'll again tap into this attribute and increment it over and over again. And this will happen for object 3 as well. Now you can imagine that this counter is basically acting as a shared attribute. This attribute is same for object 1, object 2, and object 3. All of the objects are basically referring the same variable which belongs to the entire class as a whole. And this is how static attributes function and why they are basically used. Let's try and understand the concept by using yet another example. Over here, we have a class which represents a general savings account. It has three attributes. First is an interest rate, which is a static attribute, and the other two attributes are balance and account number. Let's just not consider methods in this case. We'll just focus on attributes solely. So what we have done is, using this class, we have created two objects. First is Joe's account and the second is Mary's account. Basically, these are two separate accounts which have been made using the savings account class. So simply put, these are two objects created using the class. Now, balance and account number, which are normal attributes, will be different for these objects. The balance for Joe's account is $400, whereas that of Mary's account is $500, and that kind of makes sense. The balance of each and every object, that is the balance of each and every account, is not meant to be same. That just won't be practical, right? And also the account number will be different. The account number for Joe's account is 1111, and that for Mary's account is 2222. But there is one attribute which these two can share, which is the interest rate. The interest rate will be same for both accounts. So what will happen is, we have kept this as a static attribute so that this is existing only to the class, it is pertaining to the class, and all the objects created using the class, which in this case is Joe's account and Mary's account, will be able to reference this attribute. Now, instead of doing this, what we could have also done is add yet another normal attribute and then defining it two times. In this case, because there are two objects. Otherwise, if there would have been, let's say, 5 bank accounts, we would have defined it 5 times. But in this case, since it is static, we are only defining it once, and we're not changing it again and again just because new objects were created, as all of them basically reference this variable, and the value of this variable in this particular example stays constant. Now that we know what static attributes are and why exactly they are used, let's come back to our previous problem, which was how can we calculate, or how can we count the number of car objects which were created using the car class. What I've done is I have translated that diagram to a C++ code over here. As you can see, I've included all the necessary header files. Then I created a car class which has 3 attributes. All of them are public and are of type string. First is the color of the car, the second is the company, and third is the model. Then I defined the constructor, which sets those attributes to their respective values which the user has provided when objects were created. Now let's go to the main function. What I've done here is I've created 3 objects using the car class. The first one is named Mustang, and it's a red Ford Mustang. The second one is the Prius, which is a blue Toyota Prius, and the third one is Golf, which is a green Volkswagen Golf. And just for reference, I also printed the color of the Ford Mustang, or the Mustang object we created, and as we all know, it is red, and we can see that it was printed out as expected. So now what we need to do is first to count the number of vehicles, or rather the objects which are created using this class, we first need to introduce a static attribute, right? So what I'll do is in the public section, under the public one itself, I'll create a static attribute which is count, and this variable, which is bound to the class rather than to the individual objects, will hold the number of objects that are created. I'll quickly initialize this to 0, because we know that when no objects were created, the count should ideally be 0. Now the question is, how do we change the value of the count, or rather where do we change the value of the count? To create objects, what happens is, for creating objects, a call to the constructor is made. So I think this will be an ideal place where we can make a call, or rather where we can change the value of the static attribute, which in this case is the integer count. And what we'll do is we'll simply increment it, and after that, in the end, I'll just print it, or rather let's just remove this one altogether, and we can access it using the name of the class, since it's the attribute of the class 2 and it is shared across all of the objects. And let's just see how it plays out. Now if I quickly compile this code and then run it, you can see that the output we get is 3, because we have created 3 objects. First is the Ford Mustang of color red, the second is a Toyota Prius of color blue, and the third is the Volkswagen Golf of color green. Now what we did was we accessed the static attribute using the name of the class. But as I also mentioned previously, we can also do it using the name of an object too, right? Because it should not make that big of a difference. So what we can do is we can just do here Mustang dot count, and let's see if it works. And I get the same output, which again is 3 because of 3 objects created. First is the Ford Mustang, the Toyota Prius, and the Volkswagen Golf. And this is how we can use static attributes in some general cases. This case we saw was wherein we want to count the number of objects that were created, but they also have other applications as well, wherein we can use static attributes really well, where other normal attributes kind of fail to deliver, right? Now that we have understood the concept of static attributes with the help of several examples, let's move on to look at something different, which is a static variable and static methods. Now, as the name suggests for both of these, static variable is nothing but a variable which is static, which pertains to a class, which is singular for the entire class, and all the objects which are made using that class or built upon that class can access to that single variable, and that variable is referred to as the static variable. Similarly, a static method in this place is basically a method which again is pertaining to an entire class, and all the objects made using that class will have access to that method, and that method is singular. Now, you won't recently in the example we took and in the code that we wrote, we actually use static variables. In this case, you can see that the variable count, which is of type int, is static. And this is basically how static variables are used. This is one use case of static variables. So now that we have seen that, let's talk about static methods to be more precise. So yeah, so what we'll do now is we'll create a simple getter method. Now, if you don't know it, then getter method is basically a method which is used to get data from the object. So what we'll do is, in this case, we'll make a static getter method which will return us the variable count, which is also a static variable which holds the number of objects that have been created. So let's just do that. First, we'll declare that whatever we are going to declare over here or define over here is going to be static. And now that it's a method, we'll just write the return type, which in this case is int, and we'll just name the method. Let's say it's get count. Next, we'll just write the definition, the body of the function, which does nothing really. It just returns the count which we have got over here. So yeah, that is it. That is all we need to do in this case to define a static getter method which returns a static variable. So what we'll do now is we'll just comment this out, and we'll write another print statement in which we are trying to call that method. And let's say we do that first using the object. Let's say Mustang is an object which is made using using car class, sorry, and we'll just give it a call, give the function a call, the get count one, and we'll just add an extra line, and yeah, that is it. Let's just try and run it now. If we compile it once, and the output which we should get is 3 because we have created 3 objects, right? So in this case, the value of count should be 3, and since this function is doing nothing but returning it, the output should be in this case 3, and that is all we've got. We've got the output as 3. Now, one important thing that you guys should note is that a static method can only refer to static variables, whereas a non-static method can refer to both static and non-static variables. Now, what the hell do I mean by it? Let's just give it a try. What I said was that a non-static method can refer to a static and to a non-static variable, right? So what we'll do is we'll just modify this function a little. We'll just remove the static keyword, and this makes it a normal method, right? And all of us know that a non-static method can access a non-static variable, because in that case it will be just like a general case of writing a method which is referring the variables which have been created in that class, right? So what we'll do is in this non-static method, we'll refer a static variable. As we all know, count is a static variable which holds the number of objects. So now if I try and run this code, if I compile this code, what I should rightfully get is again count, because what we're doing is from a non-static method, we are referring a static variable which is valid, right? So let's just do it, g++, and it's static.cpp, right? So if I look at the output, it executes and it gives me the value 3, and that's done rightfully. And again, if I, instead of accessing a static variable, if I refer a non-static variable, which in this case is color is an attribute, and for Mustang, since we are calling the method on Mustang, what we should get is red. So if I just compile this again, give it a minute. Wait a minute. So what I'll do is string, and now if I compile it and run it, then I get the output which is red, and that is what was the expected output. But if I do something like this, if I set it as a static method and try to access a non-static attribute which is color, and let's just compile this code again. Let's see what we get in this case. See, what we're getting is an error which says invalid use of member color in static member function, which just says in simple words that you basically cannot do that. And let's just have a look at the explanation. Why does this thing not work with the help of a diagram? Over here, I again have a class which has a static method, which is getCount, which just gets the counter, which stores, let's say in this case, the number of objects. And then what I've done is I've created 3 objects using this class, and all of these objects have their personal attributes, which in all the 3 cases is counter, which is set to 0. Now let's say I modify the definition of getCount a little. Instead of returning a static variable, we just return a non-static variable, and let's consider it to be the counter which all the objects hold, and the value is 0. Now what will happen in this case is when this static method is called, and in it, if we refer to a non-static member which is basically counter, right? We just assume that in this method we'll be referring to a non-static variable which is counter. So what will happen is there's no way the compiler will understand which copy of the non-static member it is supposed to access. Now what do I mean by that? So basically what will happen is each of these objects, object 1, object 2 and object 3, all of them will have their own copy of counter and of all the other non-static members as well, whereas the static members are singular for all the objects of a class. So what happens is getCount is aware of the existence of object 1, object 2 and object 3, and when we ask for counter, it just does not know which object is it supposed to refer to get the counter variable. And that is why just because of the inability to make this decision, and there is no basis upon which the compiler can make this decision, we cannot refer to non-static variables in static methods. In this video, we saw 3 different things. First, we understood the concept of static attributes, then we had a look at static variables, and then also had a look at the static methods. Now, things might not make sense right away, and it's completely normal if you feel that this topic is a little difficult, because you're not alone in that, I can say that. So yeah, what you can do is, but you can rewatch this video over and over again until you feel confident, and if there are any doubts or queries, you can just post them in the comments. And yeah, we'll always be happy to help out and reach out to you. So thank you so much for watching, and stay tuned for the upcoming videos.